Hi, we're the security group. Hopefully this presentation is demystifying for you.
I'm Travis Berry, and I'm going to tell you about some of the techniques used for airport security. Airport security refers to keeping the airport and the plane safe from crime. The most common security is a metal detector that a passenger walks through. Also, there are many explosive detection machines that include X-ray machines or puffer machines. A puffer machine is a device that is able to find explosives and illegal drugs. It does this by releasing multiple puffs of air to brush particles off the person, then the machine automatically collects them and analyzes the particles within a matter of seconds. Also, just recently being implemented is a full body scan, which creates an image of the person's body to look for hidden objects that someone may be hiding underneath clothing. It does this by using an extremely high frequency radio wave, which reflects off the body to make an image that will show objects hidden under the clothes. This process takes about 15 seconds.
Hello, my name is Jason Watkins, and I'm going to talk to you a little bit about network security. Network security is a branch of computer security and information security. And the job of network security is to prevent attacks on computer systems that are connected to each other through a network. There's a number of different tools that can be used in network security, and some of them include antiviruses, firewalls, encryptions, strong and constantly changing passwords. There's also a number of ways that a network can be attacked. DNS attacks, IP spoofing, password attacks, malware. And then network security is pretty much crucial for any companies, and it's also important for even small networks at homes and even smaller business. And the strongest networks are typically found in government systems.
I'm Michael Fitzgerald, and my topic is cryptography. Encryption and hashing algorithms are the tools we use to verify identities, ensure data integrity, and keep prying eyes from sensitive data. Cryptography primarily uses mathematics to change data into another form that to the casual observer is garbage, but that can be later transformed back into its original form by an authorized user. For instance, say that you want to send some secret data to someone else over the internet. If you just send plain data, a malicious person could capture that data as it traveled, and then they would know your secret. By using cryptography, you can encrypt that same message and send it without the fear of a third-party access. Another function of cryptography is hashing. Hashing is used to create a unique value based on data. If any bit of the data is changed, the hash value changes. It is impossible to create two pieces of data with the same hash. It's possible to create data from a hash. We can use this to verify that data has not been changed. As computer professionals, it is our job to use cryptography to protect others from malicious users.
One of the most notable areas of cybersecurity is hacking, and more specifically cracking. I'm Brad Tenenholtz, and I'm going to talk about one specific area of memory exploits known as memory allocation exploits, or malloc. Memory allocation is the means by which we store variables on a hard drive. In Python, when we declare variables and set values to them, those values are stored in the computer. But what if we allotted 500 gigabytes worth of space to a 17-character variable? In that case, the hard drive would be entirely overwritten by that one variable, and that is the first danger of memory allocation cracking, a loss of information. The second danger of cracking is the opposite end. What if I allocate 17 bytes to an 18-byte string? In that case, we run into the opposite problem. Without room to store the rest of the string, that loose bit drops into the 18th byte of the hard drive, which by Murphy's Law will never be matter solitary. It will be a core operating system, which could, depending on the byte, entirely shut down your computer's ability to function. Luckily, those exploits are as old as time itself, and massive security software is fairly able to deal with these attacks. Nonetheless, experimental operating systems and non-protected systems are absolutely at risk, and that's why we as computer people should be aware of them.
Hi, my name is Terrence Ellison, and my topic is viruses and malware. Viruses work very similar to the kinds of viruses that can cause you to catch a cold, or miss work, or even miss school. Viruses are malicious computer programs that can copy themselves once infecting a computer and cause a whole myriad of problems. Malware, short for malicious software, secretly accesses a computer without the user's informed consent and refers to programs such as Trojan horses, rootkits, and backdoors. Rootkits, for example, allow malicious users the ability to gain unauthorized admin privileges onto a server. This, in the wrong place on the wrong hands, allows crooks and thieves the ability to get a hold of your logins, credit card information, and other sensitive information. Both viruses and malware can damage computers, steal information, and cause plenty of headaches for those who are trying to remove them from their systems. Thank you.
Thanks for watching. Hopefully security is a lot less intimidating now.